Simplifying radicals is one of those topics that is very important since most higher level math classes will require you to keep your answers in simplest radical form. And it's one of those topics that a lot of students struggle with because they just want to type it into a calculator and write the decimal. So a lot of lower level, maybe Algebra 1 and below, will use factor trees where they just start listing out all the factors and then will circle repeated factors and then write that in radical form. But I find that less efficient. It takes longer and it's a lot more writing. So what I like to do is use the perfect squares and figure out which perfect square factor, which largest perfect square factor divides our radical. So the first thing we want to look at there is what are the perfect squares. And so this is a list that you should have a lot of these memorized, but if you don't, it's really easy to create this list. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and if we keep going, we get 25, 36, 49, 64, 81, and you're usually pretty safe there. And those ones are the ones you should have memorized. If you can go higher, it's even better, because you might get 11 squared, which is 121, 12 squared, which is 144, 13 squared, which is 169, and 14 squared, which is 196. You can keep going from there. 15 squared is probably the last one that I have memorized at 225. So we can put that one on there too. So those are your perfect squares all the way up to 15. We're not going to need 1 since 1 doesn't reduce anything. But let's look at some examples where we're going to use these perfect square factors to reduce our radical. And let's say we have the square root of 8. So we want to figure out which of these perfect square factors, the largest of those perfect square factors, divides 8 evenly. So we can start with 4, since 9 isn't going to divide 8, and anything greater than that's not going to divide 8. And so 4 does divide 8. So we could break up 8 into the square root of 4 times the square root of 2. So the reason for this, once we know that there is a perfect square factor that divides our radical, we can reduce that because the square root of 4 is 2. That's on our list. We know that the square root here is the base of that exponential part on the left there. So then radical 8, or the square root of 8, would simplify to 2, which is the square root of 4, times 2, or times the square root of 2. So square root of 8 reduces down to 2 radical 2. If we look at a couple more examples, if we have the square root of 27, we could try 25, because 25, we're going to start with a number less than our radicand. 25 doesn't divide it, 16 doesn't divide it, but 9 does divide 27. So that would be the square root of 9 times the square root of 3, and then that becomes 3 radical 3. Let's look at, we'll do radical 32. So we could start with 25. 25 is not going to divide 32, but 16 does. So that becomes square root of 16 times the square root of 2, which would become 4 square root of 2. Now, sometimes you get multiple numbers underneath there that can divide. So if we look at, let's say, 52. So 52 isn't as obvious. We can try 49. That doesn't work. 36 doesn't work. 25 is not going to work. 16, we can try that. 52 divided by 16 is 3.25, so that doesn't work. 52 divided by 9 doesn't work, so we have to go all the way down to 4. So we end up with 4 square root of 4 times the square root of 13. So the largest perfect square factor that divides 52 is 4. So that would become 2 square root of 13. What about 108? So 108 is an interesting one because 108 is divisible by 9, but that's going to leave us with a radical that could still be reduced. So we want to make sure we're dividing by the largest number from our perfect square list that divides 108. So even though 9 is a perfect square and it divides 108, it can also be divided by 36. So that would be the square root of 36 times the square root of 3, which would reduce down to 6 radical 3. And let's look at one more. Radical 294. This one's a tough one because nothing really jumps out. So we could divide by 144, see if that one works. We could try 169, that doesn't work. 121, 100, 81, none of those work until we get down to 49. So that ends up being radical 49 times radical 6. The square root of 49 is 7. So that ends up being 7 times the square root of 6. So I prefer this method. It requires using some memorization to know your perfect square factors. Like I said, if you don't memorize that list, you can always recreate that list quickly by just counting 1 to 15 and squaring each of them. And then we're using these perfect squares to see what divides our number evenly, and then that gets reduced down as our perfect square factor. So I hope that helps. If you enjoyed that, please subscribe and stay tuned for more videos.